Hi, my name is Nick Carducci, and I'm presenting my project on quantum. Was the 26A session, and I just finished it to the point where you can actually pay money to see the actual product, but I'm going to take you through it now. The problem that I'm solving here is essentially trying to teach how quantum actually works, and in this way I am creating the first universal quantum application layer. That means that this is not a suite of embeddings that you have to choose to for your specific domain. This can detect your data schema being a table, or either tab or comma separated, or prose like code or text, and that's how you make a model. And you can then test against that model with the same schema of data, and you can see which part of that schema that we call them candidates your testing surface, which parts are violating the training. So it's not a Wild West where we're letting you experiment with quantum. This is genuinely an application layer where we're telling you that what quantum is good at, and we're bringing out the best of what it can provide you. There's a lot of use cases, so I actually completed research in the winter of 2026 during winter break, and then I presented on this at IEEE International Conference on Data Analytics and AI, I guess. Yeah, and AI and data analytics, and in Boston, and it was a little bit more rudimentary, so I used the first Hack Your Summer session to build out this product and explore other domains beyond malware. So quantum is interesting to use for machine learning anomaly detection, because classical is really good at remembering violations, but if your problem or your domain has too many problems essentially that you want to identify and flag for your users or your scientists, too many to label and train, this is a great way to only train on one class, or essentially proper usage. So you give it how code or a table of data should look, and then you give it the testing surface, and it will identify which pieces of data is problematic. So if you look at it as from a legal perspective, you can say that the one clause is contradictory to your training contract or your training rights, and then you can flag that clause without having to use humans to look over every single line. What's interesting about my patent pending pre-processing for this quantum is it uses something called a tuple, but essentially it allows you to introspect inside of the flagged surface, the testing data, to see which individual line is a problem instead of just the whole contract. So the way it works is, on your left you get to enter, you can paste or upload your data that you want to create your model from, and on your right, this is where you paste or upload the data that you want to test against that model. It can be a table or it could be prose, like you see here. The nice thing about this handoff is that you can run the test as many times as you like, because it runs on front-end JavaScript, meaning your client device, so it costs only as much as electricity for you and your processor. But modeling, we charge a certain amount through Modal, and we give you $30 a month complimentary, so you can get your bearings on how modeling works. So the demo has pre-made models where there is no source text box, but the testing area is editable. And I have these little badges here that gives you an idea of what configurations actually show an advantage over classical comparators. Essentially, any classical contemporary anomaly detection models, that you can see how they compare to our system. And when it has a badge with these indications, you can see that the level works well. Also, the configured head, they call it, being OCSVM or matrix or diagonal Mahalanobis. The levels, intra versus inter, is essentially, inter is like line by line or clause by clause, and intra is within each line. So for cybersecurity or code, intra would be the parameters, inter would be the callers. So you can see, you can analyze your data each different way. If it was a table, like industrial, intra is row by row, or inter is row by row, and intra would be the sequence of columns within each row. So for legal, there's also an interesting congruency case where you can see if there's fine print within the candidate or your testing document that countervails itself. So that's a good way to see if someone is trying to cheat you out of something. If it's gray, that just means that the model doesn't have anything to fit or score against. Any fit to score against. Red would be where it's actually counter to the training, and green means it's benign. So 26B, I spent a lot of time, other than my other projects, creating the account feature, so it's like so you could actually use it. Essentially, I made this like after Hack Your Summer and up until now, where you can see how much it would cost. Again, I give you $30 a month to try it.